Acid rain analysis by standard addition titration. Introduction.
Acid rain is an environmental phenomenon that has generated great interesting and public debate. Today, its caused and effects on the environment and the human health. It's mainly caused by the dissolution in the rainwater of sulfur and nitrogen oxide emitting to the atmosphere. We generated solution with a pH lower than normal. Analyzing the acidity rain of the snow and the essential to understand the extent of the problem and the proportion effect solution. One of the most commonly used techniques to determine the acidity of the rain sample is a titration, an analytical method that allows to quantify the concentration of acid present in the sample. The producer described in the paper used as standard addition titration, which involves standardizing an sulfuric acid solution with the sodium hydroxide and then compare into the rain sample. This method, besides being accurate, is desirable for general and analytical chemistry laboratories, since it required basic instruments such as the Brwd and the pH meter, and allows obtaining readable results on the acidity of the cold rain or snow. The analysis of acid rain by titration not only contributes to the scientific training for students, but also provides relevant data on the environment monitoring and decision making, air pollution control police. Keywords: Standard addition titration, a type of titration where no amounts of the standard are added to the analyte to determine the concentration. Equivalent point, the point in the titration where the amount to titrant ending is a stoichiometrical equivalent to the amount of analyte in the sample. pH meter, an electronic instrument used to measure the pH of the solution. Micropipette, and a laboratory instrument used to measure and dispense very small volume of liquid with high precision. Titrant, the solution of no concentration that is added to the analyte during of titration of rate with it. Analyte, substance whose concentration is to be determined by chemistry analysis. Standardize, the process of determining the exact concentration of the solution, usually by comparing it to a primary or secondary standard of no concentration. Gran graph, a graphical representation of the potentiometric titration data that allows for more accurate determination of the equivalent point.
Contextualization. Acid rain affects many regions around the world, mainly caused by the emission of sulfur and nitrogen oxides that react in the atmosphere to form sulfuric and nitric acid. These pollutants come from industries, vehicles, and energy production. When it rains or snows, this acid dissolves in the water and falls to the ground, affecting ecosystems, monuments, crops, and even human health. But how can we measure how acidic a sample of rain or snow really is? This is where the article proposes an educational and scientific solution, allowing students not only to study the problems but also to measure and verify it themselves in the laboratory. Methodology: the traditional method with the micropipette and the nitrogen purge.
This is method normally used by the researchers in the special laboratories because it's the most accurate. A micropipette is used because the acidity of the rain is so low that only a minimal amount of the base is needed, less than 1 milliliter for 100 milliliter of sample. Throughout the titration, nitrogen gas in the passed through the solution because carbon dioxide from their air can dissolve in the water and from carbonic acid, which react with sodium hydroxide and affects the result by making it appear that the sample is more acidic than it really is. This means that this method is very accurate. It requires a strict technical control, special equipment, and a lot of precision when helping search small volumes.
On the other hand, standard addition titration. A standard titration of a dilute sulfuric acid solution is performed adding sodium hydroxide and measuring the pH at each step to determine the equivalence point. The titration is the repeat, but this time 100 milliliters of rain samples is added to the same sulfuric acid solution.
When comparing the amount of sodium hydroxide what was needed in each case, one can calculate how much acid was present in the rain sample. This method relies on the graphical tautology Gran plot, which allows us to determine the equivalent point more accurate even if we do not have a very abrupt pH change.
Analysis and results. In the first column, corresponding to the standardization of sulfuric acid, the volumes of sodium hydroxide used range from 9.35 to 9.52 milliliters, with an average of 9.45 milliliters. These results are used as a reference point for the following titrations. In the second column, when adding the simulated acid rain sample, the volumes increased slightly, ranging from the 0.20 to 10.52 milliliters, with an average of 10.40 milliliters. The difference from the standardization is 0.95 milliliters, which corresponds to the acid content added by the simulated sample. In the third column, using the micropipette method with the same simulated sample, the volumes were much lower, around 0.89 milliliters. However, the calculated molarity was exactly the same as in the standard addition method, 4.45 times 10 to the minus 5 molar, validating the accuracy of the simpler method. In the last columns, the results from real rain or snow samples are presented. Using the standard addition method, approximately 10.34 milliliters of sodium hydroxide was used, with a molarity 4.45 times 10 to the minus 5 molar, very similar to the simulated sample. In the previous year's measurement using the micropipette, only 0.73 ml of sodium hydroxide was used. In the calculated molarity was 3.65 times 10 to the minus 5 molar, slightly lower. In all cases, the standard deviation was low, demonstrating that the results were consistent and reproducible, provided that the procedure was properly followed by students. The consistency of the result between both methods, especially with the simulated samples, supports the use of the standard addition methods, which is simpler and does not require nitrogen pairing. In the real samples, the difference between the methods was approximately 15 to 20%, which is reasonable since environmental samples may contain basic substances such as dust that can affect the acidity. In one of the cases, a negative value was even obtained, indicating that the sample contained more basic substances than acid ones.
Conclusions. 1. The standard addition titration method proved to be equally unreliable. The results obtained were very close to the calculated values, which validate its use as a helpful technique to the measure and acidity of rainfall. 2. Beyond techniques, the practice connects the students with the real environment problem, turning the subject of acid rain for a material into a meaningful experience that fosters environment awareness.